I think a lot of people would be surprised if they go out in the market and look at what's available and accessible in terms of manufacturing capability versus cost now. If you really want to do it all yourself, it's there.
Yeah, it is, and I think the prices just keep dropping. Like, even today, stuff is cheaper than what it was a couple of years ago.
Mhm.
There's companies out there that are happy to help too. They'll help recommend your components and get you all set up with what you need to do it.
Welcome to Making Sparks, the podcast where we ignite your passion for metal fabrication and fuel your business success. Join industry leaders and dive deep into the world of metalworking. From business insights to tips of the trade, Making Sparks is your forge of knowledge. During each episode, discover success stories, innovative solutions, and expert interviews that light the path to business growth. Subscribe today and grow and improve your company, and let's make sparks fly together.
Hey, what's going on, Metalworking Nation? Welcome back to Making Sparks, sponsored by Eagle Lasers. Happy to be with you again this week, and we've got an awesome show lined up. It's a little bit on the techier side, so if you're into manufacturing processes, machine tools, and really interested in the accessibility of technology, you're going to want to stick around for this week's episode. Joining me today, we've got Travis Mitchell. He's a full-time content creator now who's built in his garage several pieces of fabrication equipment. We're going to talk through a lot of the nuances and the challenges that you might expect with that type of project. Without further ado, here's our show with Travis Mitchell. Welcome to the show, and I must say that's an amazing backdrop for those of us watching the video here.
Yeah, thanks for having me today, Brendan. I'm excited to talk to you.
Yeah, man. I've been watching your YouTube videos for a few years now. I think the algorithm connected us on YouTube, and I was like, "This guy is crazy."
Yeah, I get that sometimes.
And I'll put a link to Travis's YouTube channel in the show notes. Absolutely, that's where most of your content is.
Yeah,
I'm assuming. So the highlights though, Travis has built in his garage a fiber tube laser, a metal 3D printer, a flat sheet cutting fiber laser, and you're working on a new project in the background, like right over your shoulder there, that
yeah.
is ongoing. If you want to tell us a little bit about that.
Yeah, well, the thing that happens once you start doing YouTube for a while is that companies reach out and would like you to test out their products. So, I had just built my own DIY CO2 gantry laser machine, and then like 2 months later, I got a request to test out a machine. I don't have room for 2 CO2 lasers, so it's like, I guess I'm just gonna disassemble the machine I bought because 'cause they're pretty close to the same size. And you can see here, I have 0 room left in my shop. So anyways, I thought, well, I'll take all these, CO2 laser components and just turn it, into a Galvo style machine instead of a gantry style machine. So I'm using the same laser source and motors, electronics. All I had to do basically was just buy the Galvo head to hook up with it.
Okay, so that seems reasonable to you,
To me,
right?
I'm
If we
I'm
back
always
up, if
I'm
we
always
back
looking
up,
for an excuse to build another machine. Come
right.
on.
So I wanted to talk about how did you get started in this world? Because I went and looked on your website and did a little bit of background, and you've got a very solid portfolio of graphic design and art and media. How did you go from that to occupying your garage with homemade machine tools?
Yeah, I'm still not really sure how it happened. Yeah, basically I had a long career in graphic and web design programming, and I was getting burnout on it. I bought a 3D printer, started doing some 3D printing. It was
Okay.
like, this is absolutely incredible that I can 3D model something at home and just like have it in a couple hours. From there, it just kind of took on a life of its own. I'm like, oh, there's all these other manufacturing capabilities out there, digital manufacturing
Mhm.
can really give you some other capabilities. And so I started off with like, oh, I'll buy a cheap CNC router kit and build that. And I started doing a little bit of that. It just it just kept snowballing. I was like, oh, there's all this other stuff. And then eventually I came across fiber laser cutting. And I was like, this is freaking incredible technology, but nobody's DIYing it yet. And so basically, I took it upon myself to see if I could figure out how to do it.
That is really a unique conclusion to come to is, "Oh, nobody's doing this. I should do it. Yeah,
Yeah,
let's figure it
exactly.
out," right? Not, "Oh, I bet there's a reason nobody's doing this," but, I think your points are totally valid. I've got a bamboo P1S sitting right here, and I bought it for the same reason because everybody was like, "Finally, you can work on 3D printing instead of the 3D printer,"
Exactly. They
right?
just work now.
And I had like one of those really cheap Chinese CO2 lasers, about
Yeah, the K40s or
the
something.
K4.
Yeah.
It's an original OG K40.
Yeah,
It's still in pieces in my garage. I haven't put it back together, but 13 years ago, and it was pretty functional for, I don't know, less than $500,
right.
something like that. My wife thought I was crazy at the time for owning it, but you know, we made tons of Christmas presents on it.
Right,
Right,
right.
once I got her into it, she
Yeah.
was like, "Oh, wait, yeah, this is awesome, this is
Yeah,
great."
it took some convincing from my wife too whenever I purchased my first laser, CO2 laser.
Yeah,
I was, like, trying to justify every angle why I need this machine that I don't know what I'm gonna do with it yet.
yeah, yeah, it's just owning the capability to own it, right? I'd rather
Yeah.
have it and not need it than need it and not have it, right?
Yeah, it's the right tool for the job, and there's so many different ways you can make things, and being able to 3D print parts or
Mhm.
cut flat sheets for parts, and it's just all of them working together.
Yeah, so all of them working together, your shop is now at the point where you have enough manufacturing capabilities in-house to pretty much do whatever you want.
Yeah,
That's and,
it
that's a
sounds like
goal to
it's
aspire to, but
well, it sounds really incredible, and that's how I viewed it at first, but now it's like I've hit the other end of the spectrum where it's like, I have so many opportunities. It's like, where do I start? Like, I can do anything.
yeah.
So there's kind of this on the other end of the spectrum when you have all these different options, it can become, I guess, a little confusing rather than a straightforward, "Here's what I'm gonna do."
Mhm.
Yeah,
Yeah,
but
I can
that's
only
my own
use one of
problem.
these machines at a time,
Yeah.
and because it's DIY, I'm gonna go ahead and assume there might be a little bit of hair on each one of them, but you can still do everything that you wanna do in the
Yeah,
garage,
right, right, yeah,
and I really think that's a big part of the future of manufacturing is the accessibility of the technology out
yeah,
there, and what what you're doing, I think, is really important, is developing working combinations of the technology stacks. Right. I've got a
yeah.
background in machine tool building. That was my first, like, real big boy job out of college. Was I worked for a machine tool OEM, and I got to see soup to nuts. It goes from electricity to precise motion with, laser control and all sorts of fun stuff. And I've got a respect for the amount of configuring and testing and development that goes into all of these machines. And, for us on the machine tool side, I mean, we were just building the motion platform. You're doing it all. You're doing the integration of lasers, you're dealing with cutting heads, you're making it work with software packages. I mean, tell us a little bit
Yeah,
about
yeah,
kind of how
yeah,
you approach the design of a new machine, and sort of how do you concept it? How do you approach this complex of a problem, right? I
yeah,
want I want this machine. Let's break this down into components and
sure.
and attack it one by one.
Yeah, that makes sense. Also, on what you were saying is, the software has really been a huge part of it too. I use, Fusion, and that
Guilty over
has
here also.
yeah, that has just been totally incredible because I can make one 3D model for a project. I can export parts to my 3D printer. I can send parts to my CNC mill or router. I can also export my files for my laser. So it's like I can get the output from that software for all of my different machines, which makes the workflow so easy. So, anyways, back to conceptualizing a machine. Basically, it starts with reading a bunch of user manuals. If I want to build a certain laser type, it goes to seeing what types of brands of laser sources are out there, reading their user manuals, and then while doing that at the same time, seeing what different controllers are available,
Hmm.
and then piecing together the inputs and outputs and pins. Can this controller actually control this piece of hardware? That's usually the backbone of it. Once I can settle on the main controller and yeah, usually a laser
Hmm.
combination, then from there I can start kind of modeling around that. you know,
Yeah, yeah. It's all start at the brain. Okay,
Start
that
at the
makes
brain,
sense.
yeah. And also, for like the more complex projects, like the metal 3D printer, it was trying to understand like how do these gas systems work? There's a closed loop recirculating gas system. So trying to understand how that all works, so I can understand what components I needed to buy, how it was all going to be wired into the controller. Yeah,
Yeah. How do
and
you?
I just build and iterate on that as I gain more information. I can actually start putting the physical 3D model together more based around those components.
Okay,
Yeah.
that makes some sense.
You can't spell high end without DN. If you're serious about taking your shop to the next level, it might be time to stop thinking in terms of good enough and start thinking in terms of capability, flexibility, and my favorite, automation. DN Solutions is helping manufacturers move into true high end machining with their SMX multitasking series, the DVF 5 axis machines, and advanced automation solutions designed for shops that want to run smarter, faster, and more competitively. The SMX platform gives you the ability to combine multiple operations into one setup, reducing handling, improving accuracy, and helping you get complex parts out the door faster. Their DVF 5 axis lineup delivers the precision, rigidity, and confidence manufacturers need for today's demanding aerospace, medical, and high performance applications. And when you pair those machines with automation, you're not just buying equipment, you're building a more scalable business. High end parts, high end capability, high end thinking. Because you can't spell high end without DN. Learn more at dnsolutions.com.
So you mentioned shopping by user manuals. So
Yeah.
that's the opposite of how I think most people buy a lot of this equipment. They go on the website and they're like, oh, look at these specifications and stuff like that. It's like, no, you have
Yeah.
to read the 100-page document if you actually want to use it.
Yeah. There's that, and the other, I guess, not really trick, but the other method I use is that I'll also try to find information on commercially available machines. If I
Okay.
wanna make a laser cutter, I'll go see what's out there on the market, and usually on their websites and documentation and stuff, they'll tell you some specs. Sometimes you can see
Yeah.
specs, sometimes you can see some of the components they're using. Try to piece together all these little bits of information from different sources and just, like, put it down in documents every time I find something that might be useful. Try
Yeah.
to
It's like,
piece
here's a
try to piece
controller and a laser
Yeah,
combination that somebody made work together at some point, and
exactly.
there's hope. There's hope for
It
me.
exactly. I just need a little thread of hope that something might work together, and did it go for it.
Nice, nice. Have you found over your projects sequentially that that stuff is getting easier to find and information is becoming more and more available on certain things?
I don't think information is necessarily more available, but I'm getting better at knowing where to look for the information.
Okay.
I'll also bring in that here in the past couple projects, I've started toying around with the AI to help me a little bit,
Okay.
asking it some complex questions that, help guide me.
That's what, I was kinda naturally gonna go there. Here's a 100-page document. Can you tell me what outputs this supports and, what weird stuff it does? And AI is really good at reading documents and giving you a summary
Yeah.
of them.
For me right now, it's still a very love-hate relationship. It has definitely helped me at times, but for me to get to the point where it does help me, it sends me down so many rabbit holes.
Mhm.
It's just luckily I know a little bit, so I can kinda call its bluff when I'm like, you like,
Yeah, you're
"You're
on drugs.
hallucinating.
"Hey,
You're
Claude,
hallucinating. You
you're on
you don't know what
drugs.
you're
Yep,
talking
you're
about."
tripping."
And so when I use it, I'm always in this constant battle of is it really telling me something useful, or is it just gone off the rails and I need to dial it back and send it
Mhm.
in a new direction? I feel like it takes like 80-90% of trying to get it to get you the right answer before you finally get it.
Right, right, and
Yeah.
and and if you're doing it right, I think you do still learn stuff along the way.
Yeah,
Like, "Oh, yeah, this makes sense," or, "Here's a capability I didn't really know about that the AI suggested, but I wasn't going to use until it suggested it."
exactly. And also, one other thing is I've tested ChatGPT and Google Gemini. And it's funny for some questions, Gemini is so much better. I don't know if it's the data set it has or what, but it can get me the answers really quick. And then on other question, it's like it doesn't know what it's talking about, but ChatGPT can give
Yeah,
me a very specific answer. So I find myself bouncing back and forth, making them check themselves because the types of answers I can get are so different between the two.
yeah, at our company, we've got a Claude subscription that all of our guys use, even our service techs use it for document generation. So creating a user manual on a new feature or a new procedure that we're improving, they can, hey, here's what I did. Here's the images. Make the document right.
Yeah,
Here's the valuable information. Make it look nice and readable to somebody that doesn't know anything about machine tools. I agree with you on Gemini because Gemini is great for looking stuff up on the internet because it's using the live internet
yeah,
and then summarizing that. Whereas some of the other models, like they've got a training set that might be 6 months old, or
right.
it won't include like new information. So searching for news. So it's much more like focused on specific output or gathering information. And I do think there's advantages and disadvantages to all these different models of that.
Yeah, exactly. Yeah, exactly. I'm finding the same thing.
Yeah. And then somebody's going to write something that just links them together. It's like
Hopefully, yeah, hopefully.
dump the output of Gemini into Claude or ChatGPT, and
Right. Right.
and we start the iterative loop that way.
Yeah. I also find annoying how agreeable they are to my
Mhm.
questions, and they like to just tell me that I'm right all the time,
Yeah,
and, it's like, sometimes it's so frustrating to get a good answer.
right. You need to be a little self-deprecating
Yes,
to work with
yes.
AI. I love that.
Yes.
It's like, wait a minute, I'm not that smart. That's why I'm asking
Right.
you in the first place.
Exactly.
That's awesome. So back to machine projects. You started full-time YouTubing a few years ago, 2, 3 years ago at
Yeah,
this point?
I think it's been about 2 years now. Yeah.
Okay. So what was the first big project that you were like, "All right, I'm gonna make a real content series
Yeah, the
about
first
this?"
big one was my first flat sheet fiber laser cutting machine.
Okay.
Nobody had ever done that before on YouTube, so, I got a lot of views from those videos, and it boosted my confidence quite a bit, like, "Oh, wow, like, I'm stepping out there and trying this thing, and people
Mhm.
are responding really positively." So, yeah, I just kinda rolled from there.
So going into that project, what were kinda your driving, "I want the machine to be able to do X, Y, and Z." What were your goals about on that machine, I guess?
My goals were very basic. My goals were just, can I understand how this machine technology works and build a machine that does something? You
That
know,
cuts
the
apart,
the
yeah.
the goal was just to see if I could make it work.
Yeah.
It's very simple, and you have to understand that from my background, this is like way out of my league. I was attempting something that was just really
You're
beyond.
not a mechanical engineer.
I'm not at all, and literally after my graphic design field, I told you I jumped into 3D printing, like, I really had none of this experience. I just started basically, I would buy some old machines and try to retrofit them to new controllers and make them work and stuff, so I got a little bit of, like, wiring understanding, I guess.
Okay.
To the jump to the fiber laser cutter was a huge leap,
Yeah.
and it was kind of a gamble and a risk because it's a little bittersweet story, but, like, I didn't have the money to bake it. I had done months of research, kinda figured out a ballpark of what the machine might cost if everything went to plan,
Okay.
and I figured that out to be around $15,000.
Okay.
I didn't have $15,000. And so, kind of right at the same time, my father passed away. And whenever my father passed, we had shared ownership in some hunting land that I used to do in my youth, but haven't hunted in years. And so after he died, my mother and I agreed, like, oh, let's just sell the land because neither of us won it. So we were able to sell that land, and my portion from that was $15,000. And
That
so
that
it
is
it was super bittersweet, you know, it was super sad, but at the same time, in a weird way, my father passing enabled me to take this huge leap and risk, and
wow,
I did it, and I went for it, and I went
that's
for
incredible.
it. Yeah.
Yeah, sometimes the universe just throws something at you and
Yep.
you gotta jump on, huh?
Yeah, yeah, and it was weird, it was like, I didn't know why I wanted to build this so bad, like, I had no real functional use for it other than I wanted to see if I could do it and build a machine so I could cut metal. But there was this force that was just like, "You have to do this."
That's that is an amazing story and condolences about your father,
Yeah,
but
thanks.
that
Yeah,
that is
I've only shared it with a few people, but, yeah, it was pretty crazy.
wow.
If you run a job shop, manage a job shop, or spend your day trying to squeeze more output out of the same people, machines, and hours, this one's for you. During IMTS week, the Job Shops Workshop and Networking Reception takes place on Tuesday, September 15th. This half-day program is built specifically for shop professionals like us who want practical ideas that they can actually take back to the floor. You'll hear how other shops are reducing operational costs, improving output, applying AI in shop-ready ways, and implementing automation where it makes sense. Plus, you'll get a detailed industry outlook and the chance to connect with other job shop leaders who are solving the same problems you are. If you're going to IMTS to find ideas that can move the needle in your shop, don't just walk the aisles, get it in the room. Learn more and register at imts.com.
All right, so you jump into you say, "All right, I've got the means, I've got the space." Um, you jump into building the machine. What happens first? You've got the design basically kind of loosely figured out at this point. Most of your components
Yeah.
identified. Is it just buy stuff and wait?
Yeah, it was, probably a month or 2 of you know, most things I buy are from China because that's what I can afford. I can't afford most of these US laser products. So it was yeah, it was pull the trigger, order all these expensive parts, wait a month or 2. On the first machine, I decided to go with just like a pre-built CNC gantry kit.
Okay.
That way I didn't really have to focus on the functionality of that. I could just use this kit. All I needed to worry about was how to hook up this laser to it.
Okay. I think
Yeah,
that's a good risk management decision there is, okay, let's not worry about motion. Let's just worry about the
exactly.
laser integration here.
Exactly. Yeah. So yeah, from there it was trying to figure out the laser integration and understand the gas. I had never worked with any assist gas before, so
Okay.
it was trying to understand what I needed to buy for the gas system, how to make a gas system work. Basically, on my first machine, I designed my gas control system based on like one photo I found on the internet from a commercial machine. And from that photo, it was high enough resolution that I could zoom in and see what the components were, look up the model numbers on the different components, and try to see like, oh, that's what that is. You know, it's a
Oh,
relay.
here's
Oh,
here's the spec sheet and the user manual and
e- exactly.
a
So
rabbit
from
hole there.
yeah, so from one photo, I was able to identify several of the gas system components. From there, I could look up those components and understand what they did and why the system was connected in the way that it was. And yeah, luckily it worked.
It did what you asked it to. All
Yeah,
right.
yeah. So I think probably, given that example, probably my biggest skill set isn't machine building, but it's internet sleuthing.
There you
I do
go.
I do a lot of research.
I mean, hey, engineering is information management 101, right?
Yeah,
That's a huge, huge part of every development project. And I think your comment about the gas is definitely something that people who are used to like CNC routers don't totally understand. Like your tool does most of your process, I guess, performance influence at that point. But with a laser, you've got the assist gas, you've got the focus position, you've got the laser power itself, you've got the feed rate, you've got
Yeah.
the pierce,
There's a
you've
lot of
got
variables.
all these recipes to figure out from scratch, and that's really really challenging to do all of that at once.
Yeah. Yeah, there's a lot of variables, and also you can find information out there about, like, cutting parameters and stuff, and you'll find different sources, and they're all wildly different.
Yes.
So, basically, it comes down to you need to understand what the machine's doing, how it works, how when you change some parameter, what it's affecting, and you gotta be able to iterate and do your own testing to understand how your machine's gonna work.
Yeah. Yeah. So I mean, this is kind of the I have a little bit of a love-hate relationship with some of the Chinese stuff
Mhm.
because,
Most
uh,
people do.
on one hand, I mean, the lasers I sell are true production machines, right? They're
Yeah.
designed for 24/7 operation in commercial operations that make millions of dollars per year. And then you have but that access to that technology is never gonna happen at that price point.
Right.
Whereas you now have a lot of these low cost solutions, you're right, they do not perform the same at all, despite doing the same thing. But it is heartening to know that the technology access has gotten to the point where a a man can build this from components in his garage.
Yeah, right. The biggest hurdles I've had from the Chinese components is, I guess, translation issues with user manuals and not well documented user manuals, as well as finding support when you need it. Like, it's
Sure.
a lot of these companies, I'll email questions to, like, directly to the manufacturer, and I just nothing.
Nothing.
I'll get nothing back.
Not even they have a WeChat number or
Yeah, it always ends whenever I do make contacts, it always ends up in WeChat. Luckily, through my YouTube journey, I've made some connections with a Chinese laser manufacturer. So whenever it's applicable, I can reach out to them and say, "Hey, can you put me in touch with so
yeah,
and so for using their connections?" And they're awesome about supporting me in that way.
that's awesome. They
Yeah,
treat you like a kind of a your own little OEM now
exactly.
because you got that relationship.
Yeah,
That's funny.
I help them sell parts, so they help me on the other end.
Okay, alright. Hey, one hand washes the other, okay.
Exactly, exactly. It's
I get it.
very mutually beneficial.
Awesome. So then you decided, "It's not enough to do this in 2D, and I need to make a tube laser," which is like, that's like the ultimate fab guy dream is to have a tube laser in their garage, and you have achieved that.
Yeah, it's the big hurdle with that was understanding well the controller's different obviously because it
Right.
needs to do different stuff, but the chuck for the tube, dealing not with just round tube, but square and rectangle
Mhm.
profiles. Um the hurdle for me was figuring out that mechanical system to be able to accommodate all these different tube sizes. Luckily, I can't remember offhand, but there's a guy on YouTube who just, like, puts out mechanical designs, just like, 3D animations of them working.
Okay, this is
And
interested,
yeah,
interested.
yeah, I can share you a link later. But, yeah, I found, he had shared a design for, like, a tube clamping mechanism, and so from studying that, I kinda understand the mechanical components, how it was working, and was able to base a design on
Yeah,
seeing how
because not
somebody
only does
else
it have
was able to achieve it.
because not only do you have to clamp the tube, that it has to rotate
Exactly, yeah,
quickly
yeah,
and maintain clamping pressure in all orientations
right, yeah.
and keep it roughly on center.
Yeah, exactly. And, whenever I was researching that project, I found some, like, on the market, laser cutting tube chucks specifically designed for the job, but what I found was they're all huge scale.
Okay.
They're like, I don't know, hundreds of pounds and designed to just carry huge massive tubes, which I can't do in my garage. Even just moving this chuck around to get it on a machine was like not practical at all. So I designed my little mini version that was good for a small machine like mine. And even my Chinese sponsor that sponsors many of these components, they actually put me in touch with a tube chuck manufacturer, so they would be able to manufacture my design if other people want to build a small machine like mine, which I thought was awesome. Like I was never going to do that. I wasn't
Yeah,
going to try to sell them.
it's wild how entrepreneurial they really are over there. Is any business opportunity there? It's like, yeah, oh yeah, we want to sell more stuff. Yeah, absolutely, we'll work with you, no problem.
Yeah, that and also they move at lightning speed. I
Yeah, it's almost frustrating, right?
I've never dealt with any kind of U.S. company that doesn't, it's like they're dragging their feet. But with these Chinese partners I've had, like they just move at lightning speed on everything. I don't even understand how they sleep. They get so much done sometimes so quickly.
And for the most part, it will work for a good period of time,
Yeah,
right? It's quick.
it's very quick.
So from flat laser cutter to the tube laser cutter, how much of your design and development process was compressed kind of having done a complex machine before? Going like, "Okay, now I know how to cut flat. I can adapt this to something else."
Yeah, yeah, that was a huge benefit. Having built one. Oh, actually, I built two. I built my first flat sheet cutting laser, and that was the one where I was just guessing because I had no idea how this machine worked. From there, I went and designed a flat sheet cutting machine from scratch, taking all the information I had learned in
Okay,
my first build and saying, okay, now I know how to optimize everything better, how it's going to need to work. Built that machine, and it was much better
okay,
with all my revisions. And so from there, moving on to the tube cutting machine, yeah, I had already had experience building two, so I had a good idea of what it needed to do. The main thing was just trying to figure out the chuck system. So once I got past that hurdle, it just kind of all just fell together.
okay, that's awesome. So
Yeah,
so how capable is your tube laser in terms of
yeah,
what it can cut and what how heavy of a workpiece, all that?
yeah. So I designed it to be able to accommodate up to a 6 foot length of tube.
Okay,
Specifically because I researched, ordering material. I don't have a local metal supplier around me that I've found yet. I always end up ordering it online, and I found that once you break that threshold, longer than 6 feet, the shipping becomes astronomical.
okay.
So I thought, well, if I can't afford to buy material, I'm never gonna use it, so I'll just design it for 6 foot
And
less.
that's a super important consideration because I've spent a lot of time in the metals industry, and nothing about that industry is set up for, like, retail garage use. Like,
Yeah.
they want you to go buy your, whatever onesie twosie things at Home Depot or Lowe's or whatever, and designing around that constraint is really clever.
Yeah, I don't pat myself on the back much, but yeah, I'm really glad that I took that into consideration
Yeah.
because it's a super important aspect of the machine. And yeah, also on your point, yeah, I have Home Depot and Menards around me, and they carry a little bit of metal supply, but it's like never anything
Yeah,
that I
it's been
never.
sitting
Yeah,
there for 6 months and
it's never what I need or
yeah.
want. So yeah, I can do 6 foot length. The, bore in my chuck can fit, I think, up to 3.5 inches,
Okay.
round tube, and then, think about 3-inch rectangle in one dimension, 2.5 by 2.5 square tube.
Yeah, for hobby stuff and
Yeah.
projects and basic weldment structures and stuff like that, that's incredible.
Yeah, the thing I haven't really since I built it, I haven't really used it, like, I'm just always moving at, like, this lightning speed of moving ahead.
Moving on to the next one, yeah.
Yeah, the, big project I wanna do with it is build a go-kart frame. I had 3 boys, and right now we have these little Razor, go-kart things, that we ride, but I modified one of them for me to ride and put a big motor and stuff in it, but I can't fit in this thing, like,
Yeah.
my knees are up to my chin just fitting in it, so I would like to design a go-kart frame from scratch using the laser tube cutting machine.
I think you could probably do a go-kart frame without a tube bender, just using design, and then honestly, If it was me, I'd laser weld it.
Hey, everybody. What do you think of when I say OTD? Well, in making chips, we've got lots of acronyms to deal with, but OTD is on time delivery. On time delivery is part of Hill's mission: deliver quality parts on time, every time. When I was shopping for an ERP system, I was looking for something that would ensure that we do that on a regular basis. Delivering jobs on time was something we struggled with, and I know that most shops struggle with. I think I saw recently that 70% of shops struggle with delivering parts on time. So the best decision I made in that, enter ProShop. Did you know that many of ProShop's customers quickly experience 95% or better on-time delivery rates with their customers? And now ProShop has a guide to help all shops, whether you're using ProShop or not. Visit proshoperp.com/95. Again, that's proshoperp/95 to get your copy today.
I guess kind of speaking on the same topic, as far as my YouTube channel goes, is I've already built like every machine that I've aspired to build, and I have every capability I can dream of. So I think the focus of my channel is going to start shifting to just using the machines for building projects with them now.
Yeah, go
So
karts and
I hope people still enjoy what I do whenever I kind of switch over to that. But I'm just out of building machines
yeah.
projects.
You also have machines in your shop that you didn't build.
Yeah,
So I know recently you had acquired a new fiber laser. Thoughts on what you get from out of the box buying a what I'll call a prosumer, because
exactly.
it's not a K40, it's not the $500 machine, but
No.
it's also not $100,000,
Yeah.
right?
So what's happened? Okay. So basically, here we'll back up on the timeline. Basically, I built my first DIY fiber laser cutting machine, and there was nothing on the market for the home garage use at that point.
Mhm.
And here we are a couple years later, and there's a number of these machines on the market. You have this xTool metal fab
Yep.
that's come out. The G-Wiike M2, M3 is also another small laser cutting machine. This one behind me is by the company that sponsors me, Skyfire. They sell tons of laser components if you want to build your machines, but they've also started manufacturing these smaller laser cutting machines. The one behind me I have is it's like a 2 foot by 2 foot cutting area with a 1200-watt air cooled sword, so you don't need a
Okay.
separate chiller.
I mean, so you're really at garage infrastructure level here for
Yeah. So basically, the model I have behind me, they're positioning themselves as more prosumer
Mhm.
or semi-industrial. The, like the xTool and the G-Wiike machines, they're basically taking a laser welder, sticking it on a gantry, and turning it into a CNC laser cutter. Whereby this is more focused on, we'll do one job and we'll do it well.
Okay.
They sell their laser welders separate. The pricing is quite competitive. It's interesting because just because you can build a DIY fiber laser cutting machine now doesn't mean a lot of people want to or even feel that they have the skill set to do it.
Right.
So now that you have the opportunity to buy some of these small machine, it's just like I think it's really
I pay attention to this market, this side of the market too, as somebody in the machine tool industry, because, it is the natural progression of technology, right? It becomes more and more available. I know that X tool thing is like $5,000-$6,000, something like that.
I think that's just for the
Um,
welder. I think
that's just for the well.
once you add the CNC, it's above
Okay.
10K, but yeah.
But you're less than 15, which is
Yeah,
what we talked about
exactly.
earlier, right?
Yeah. It's incredible. It took me 15 to build my first one. Now you can just have one delivered for that price.
That yeah, that's and it's a lot of capability to have in your garage, right?
Yeah.
If you're a serious maker working on cars or motorcycles or go-karts or something like that, being able to just, "I wanna make progress here and be able to design and manufacture at the same time, and I don't even wanna use Sen Cut Sen," right? It's a
Yeah. Yeah, and any, small metal fab shop, I mean, probably up until very recently, most people are using plasma cutters, but
Yep,
the difference and quality and detail of cut you get on the lasers just, I guess, unmatched at this point, unless maybe
yeah.
like a water jet or something, but
Right, and nobody wants a water jet in their garage.
Right.
Nobody wants a water jet in their garage.
Right.
No offense to water jets. They
I
they
know.
they do their job, but nobody wants that in their garage
Yeah.
for various reasons. But, I mean, I look at, okay, you've built a DIY tube laser now. Maybe is that the next frontier, is being able to do structure and weldments in your own garage? Is that a thing that's going to come in the next few years?
Yeah, I'm waiting. Well, because even these like I think the xTool and the G-Weike machines, I think they might sell them with a rotary axis.
Oh, so it's already there.
Well,
Okay.
it's kind of there. It's only you could so far it's only around 2.
Ah, okay.
And it's only a short span because you're just clamping the material with one chuck. So you actually need a second component to
Yeah,
hold
that
a long piece of material.
you're exactly right.
So
I used to sell lasers with rotary axes, and that was the first thing I always told people is it's not a tube laser.
yeah,
It cuts
yeah,
tube, but it's not a tube laser.
exactly. It can do a small little round thing, but that's pretty much its limitation. But yeah, I'm excited and I'm waiting for that first dedicated tube cutting machine to come on the market. I'll be following that closely. I'm sure.
That's awesome. So your latest project is it's a CO2 Galvo scanner
Yeah,
there. Um, and I've thought about making one of those in not maybe not the sort of recent past, but like this is something I could probably get behind. I've worked with Galvo scanners before professionally, and um, I have not yet gone down the rabbit hole of how much that would cost. This is actually a project that you seem to have started to use the existing capabilities of your shop to manufacture the machine, because now you've got
yeah.
the ability to cut custom sheet metal to provide all the enclosure work and do all that just completely internally.
Yeah, exactly. And not even on just this project, even probably the past 4 or 5 projects, I use every machine I have up until that point to make parts. I'll mill aluminum parts on my CNC router or mill. I'll 3D print some parts. I'll use my CO2 laser for cutting clear window panels. I'll use my flat fiber laser machine for cutting metal body panels. Sometimes I'll fold some simple brackets out of those parts. And, yeah, every time I just use my latest technology and add to
Nice,
it.
nice. So a press brake is next, is what you're telling me.
Well, I have one. I bought that, Langmeyer, I think it's 25T Titan or whatever. It's
Okay.
like a 2-foot by 2-foot CNC press brake, and, I've used it a little bit. I haven't got to dive into it as much as I would like yet, but I would like to. I've seen some really cool folded sheet metal parts online, and I'm like, "With this machine, I could design and make those."
Hmm.
And using, Fusion's sheet metal folding tools in the software, it makes it so easy to lay out those parts.
Right, right. It's a
Yeah,
click, unfold, done. Here
e
you go.
exactly.
Engrave the bend lines.
Yeah, and it's fun. It's cool to be able to take that a flat 2D plane and bend it into something useful.
Yeah, I think there's a lot of parts that people in their garage would like try and make on a CNC router that should just be sheet metal.
Yeah,
It's
right
and
tool for the job.
right. I'm gonna take a sidestep into the more nerdy section here.
Okay, good.
Tell me, what controls are you typically using to manage motion and process all at once? Because that's I think where people struggle to, or at least somebody who's not kind of in the machine tool world would struggle to like kind of understand what the solution needs to look like from a what it needs to do technically, what package it comes in, how do you power it?
Yeah.
What are you typically using as the brains of your machines nowadays?
Yeah, for, like, the controller software package,
Right.
it's very dependent on the machine, especially with these fiber laser machines, they have specific controllers for that.
Hmm.
For let me
But the
think.
laser controller doesn't manage motion.
They do.
They do. They
Yeah,
do now.
they do. Yeah, they're all in one. A lot of people like this software Lightburn. I don't know if you're familiar with it.
Okay, I've heard of it.
It's kind of
Yep.
a generic laser
I've
cutting
never used it, but
software.
I've heard of it.
Yeah, I've used it for, like, controlling, gantry cell, CO2 and stuff. It works great. A lot of people have come from familiar with the software and want to try to use it with these more complicated machines, but it just does not have the functionality. Basically, if you're going to build a fiber laser cutting machine, be it flat or tube, it needs a specific controller designed for that because the controller has within it an integrated capacitive sensor so that the metal tip on the laser cutting head can
Hmm.
precisely control the offset distance from your metal sheet or tube, which is never flat. It's always going to have
Right.
some bower to it. So it needs to be able to keep this distance very precise so that
Yep.
it cuts
Our
cleanly.
our machines do it hundreds of times a second.
Y-
They're
Exactly.
they're running that feedback loop.
Exactly. So, when I'm building these machines, I'm buying a controller software that's specifically designed for that because just your general CNC controllers aren't going to have that kind of
Okay.
functionality embedded into them.
Okay. So
Yeah.
so in this case, the process controller has motion as an accessory
Yeah. It's all
instead of vice
integrated.
versa.
Yes, it's got the motion control integrated and it's got the laser control integrated all into one a hardware software package. Yeah.
That makes sense.
And I've used several now. I've used for flat sheet cutting machines, I've used a Ruida controller. I've used a Ray Tools controller, and now with this machine back here, it has an All3 Tech controller. They're all a little bit different, but basically the same. you know,
Right? You can configure your motion axis.
yeah,
The menu's a
yeah,
little bit different, but the
yeah.
parameters are similar.
Everything's a little bit different in the software and wiring, but they're all same time they're all extremely similar. So if you've used one of them, you could use any of them basically.
All right. All right. Good to know. That's confidence inspiring.
yeah.
I'm moving into a new house this summer, and one of the big selling points of the house was a 4-car garage that I got plans for.
You got a plan. All right. Am I gonna find myself over there building a machine with you?
It's extremely possible at this point.
Awesome.
Awesome, man. Well, Travis, we've been going on for a little bit. It's been a pleasure getting to know you and just kind of talking DIY machine design. And I think a lot of people would be surprised they go out in the market and look at what's available and accessible in terms of manufacturing capability versus cost now. If you really want to do it all yourself, it's there.
Yeah, it is, and I think the prices just keep dropping. Like even today, stuff is cheaper than what it was a couple of years ago.
Hmm.
There's companies out there that are happy to help too. They'll help recommend your components and get you all set up with what you need to do it.
Awesome.
And then of course you always have my YouTube channel.
Right, right. Great plug, great plug.
Exactly.
We will absolutely have a link to that in the show notes. You know, you're getting up there in subscribers. Last I checked, it was like 40,000.
Yeah, yeah, it's
That's awesome.
slowly growing. My problem right now is that
Count me
it
among
just
them.
yeah, it just takes me forever to put out content because, I guess kind of my motto in making these videos is that I don't like my time wasted and I don't wanna waste people's time. So, when I'm sharing videos, like, I'm speeding through this stuff just to not waste anybody's time. Here's the important bits, but in order to get all that content to do that, like, it just takes a
Here's 8
while, so
hours of research and a 8-second montage.
exactly. So my video output is fairly slow.
I think you're one of the few channels I actually have the notification bell on,
Oh,
so
yeah.
I can see it because I've been following these projects. Like, this is cool stuff. If you're into, machinery nerd stuff and really understanding manufacturing technologies, it's absolutely great content. And you don't hold back. And like, oh yeah, this broke. This is a 2-3 week setback, or I got to take this completely apart and redo this entire subassembly because it doesn't work with the design. And it's a real honest look
Yeah.
at garage machine tool manufacturing.
Yeah, nothing ever goes smoothly, but you just, that's gonna happen, so you gotta take a step back and work your way through it.
Fantastic. Well, I'm gonna wrap this episode up. I might have you back on the show here in the future.
Okay. Yeah, it's been
Just
great talking to you, yeah.
I think there's a lot we can team up on. I definitely want to come help you design that go kart frame.
Yeah, that'd be fun. Do you have kids, right?
I have 2 boys, yeah, they're
Yeah.
5 and 2, so not
All right.
quite go-kart age yet.
Okay.
I think the 2-year-old is gonna be a go-kart kid for sure.
Okay.
We know that already.
All right. Well, when they're ready, I'll invite you over and you can put them on the trail here.
Awesome. All right, Travis, thanks so much for coming on the show. Again, we'll have links to all his content in the show notes, and I look forward to watching you get that Galvo scanner complete.
Awesome. Thanks so much, Brendan.
All right, have a great one.
All right. You too.